Hello, Math 141. Let's do another optimization. I'm going to go ahead and share my screen because I copy pasted that particular problem into the Word document. So let's see. Section 3.7, number 19. A microwavable cup of soup package needs to be constructed in the shape of a cylinder to hold 250 cubic centimeters of soup. The side and the bottom of the container will be made of styrofoam, costing zero point zero 0.04 cents per square centimeter. Oh, look at this. The other part, the top, okay, the top will be made of glued paper costing 0.07 cents. So I better be careful with that. Find the dimensions for the package that will minimize producing cost. So and we are supposed to find radius, the height, and the minimum cost. So the radius and the height such that helps the cost to be uh, minimum. And of course, what's set here, what is our constraint in this case is that the volume is 250 cubic centimeter. So I'm going to go ahead and stop sharing my screen. That way I can get my iPad involved and write some stuff down for you. Uh, Give me 1 second, please. It is connecting. And okay, whiteboard. So let me start by first, let's draw a picture. What is it that we have? We do have something like this. So this is the bottom, this is the side, and let's do the top with a different color since it's going to be costing more. The top is going to be costing more. So here is the radius. What is the volume of this cylinder? The volume of this cylinder is the area of the base, in this case, the circle, which is pi r squared times what? Times the height of our cylinder, times height. And it is given to us that the volume is 250 cubic centimeter. So 250 equals pi r squared h. And here, since we are trying to find both r and h, I'm going to go ahead and, in this case, solve for h from right here and claim that h equals divide 250 by pi r squared. So now I'll be using this. Well, what is it that we are trying to minimize? We are trying to minimize the cost. And so what is the cost for this equals, for this cup, cylindrical cup? The cost equals the cost of the side. So if I have, the side of this cylinder, let me grab a piece of paper. So right here. So think of this, if I make this as a cylinder. So a circular cylinder. So the surface area of this circular cylinder, if I just, open my paper, is the circumference of the bottom, which is 2 pi r times the height. So, and the cost of material was 0.04. So for the side, I'm going to write 0.04 times 2 pi r times the height, plus the cost of this bottom, which was 0.04 times pi r squared for the area of the base. And I have to remember that the top cos 0.07 pi r squared. So once again, this right here came, this is the area, zero, of course not here. This right here was area of the side. This was right here, area of the bottom, which is the same as area of the top. I wrote it separately because the cost is different for the material used for the bottom and the top. So let me go ahead and go to the next page. And so I have cost equals, we had 0.04 times 2 pi r h plus 0.04 pi r squared plus 0.07 pi r squared. Let's simplify this. So now I have a c, or cost, equals 0.04 times 2 give me 0.08 times pi times r. And the h on the previous page, we solved, we said that h is 250 divided by pi r squared. So 250 pi r squared plus 0. So if I add these two together, I will get 0.11 pi r squared. Okay. I can simplify a little bit. So I have C, or cost, equals 0.8 times 250. Just to double check, 250 times 0.08, okay, 20. So 20, this pi cancels this pi, this r cancels this second power. So I have over r plus 0.11 pi r squared. And notice now I have a rational function, once again with understanding that the radius is positive and the height is positive. So I'm going to be looking at pretty much my graph, but in quadrant 1. So I'm going to go ahead and disengage my my iPad. That way I can show you the Desmos to graph. I have it ready for you. So I'm going to share screen from here and go to this graph, Desmos. Graphing 0.11 pi x squared plus 20 over x. And of course, you know that I had r squared, but just x is just as good, same thing. And notice right here, I do have the vertex in here, or I shouldn't say vertex, I should say local minimum right here at 3.07, at 3.07. Once again, I'm only looking, I set my window such that I'm only looking from 0 and a little bit to the right, because I know that both values of radius and height are positive. So I'm going to stop share from here. I hope you saw this, that this is what we have, 0.11 pi. We had r squared, now I have x squared, same thing, I just different alphabet, plus 20 over r. All right, stop sharing and go back to my iPad. Okay, good, it is connecting, and here it is. So now that I found out based upon my graph that r equals 3.07, okay, we already figured out that h equals 250 over pi r squared. And so h equals 250 over pi times 3.07 squared, and that gives me roughly 8.443. I hope you enjoyed this example and talk to you soon. Thank you.